So I accidentally cut that video off, so here's the rest of the questions. Question 3, let f be the function given by, and this should be a piecewise function. Just couldn't get it on my computer screen well enough. So a piecewise function is two pieces or more of a graph, and they're defined over certain points. This first one's defined when x does not equal 5. So basically any point that's not 5 follows this rule. And when x is 5, it follows the rule of c. So if f is a continuous function at x equals 5, what is the value of c? So the word that jumped out at me, and hopefully to you, is one of these newer words we talked about this year, is the word continuous. There's actually a definition. If we were in class, like we really wish we were with the bridge, we'd be firing quizzes at you left and right, making sure you have these down. Obviously not for a grade, but just so they're ingrained in your head. So when I see that word continuous, immediately my calculus brain is saying, okay, the limit as x approaches a from the left of f of x has to equal the limit as x approaches a from the right of f of x, which has to equal f of a. We call it the three-headed monster. There should be three pieces. The left side and the right side have to meet, and then this point has to be closed. Okay, so I have to come in from the left, I have to come in from the right. That's my limit, and then this needs to be closed to make it continuous. Otherwise, it's a big gap. It's like falling in a hole. So continuous, all three things have to be true. Now, some people will shorten this up because if the limit from the left and the right are already meeting, then we say the limit exists. So we can just say the limit as x approaches a of f of x, sums that whole side up, has to equal f of a. So we're basically saying this limit has to exist and it has to equal this point. So if that's true, and they're asking us, they want to make this continuous at 5, then we know the left and the right in the function all have to be equal. So I basically just have to set these two functions equal to each other. So I'm going to say the square root of x plus 4 minus 3 over x minus 5 equals c. So if I were to plug that 5 in, which of course direct substitution is always our method, I've got 5 plus 4. 5 plus 4 is 9. The square root of 9 is 3. 3 minus 3 is 0 over 5 minus 5. So I get 0 over 0. I get that indeterminate, which means I have to manipulate this side, which comes back to seeing these radicals that we're going to see a lot of. We just have to rationalize this function again. So I'm kind of running out of room here. I am going to rationalize this function. So I'm going to multiply by the conjugate. I've got the square root of x plus 4, and then, of course, plus 3. Square root of x plus 4 plus 3. So I'm cleaning up this right-hand side. That denominator we know we're not going to mess with. And feel free to pause and go ahead and compare here. You don't have to wait for me. This radical times this radical is just x plus 4. I'm going to have positive 3 of those, negative 3 of those. They wash away, and then a minus 9, which of course is nice because this 4 minus 9 turns into negative 5. So I'm just going to cross that off and put minus 5. So I've got x minus 5 and x minus 5. So it looks like, right over here, I have 1 over the square root of x plus 4 plus 3. And basically that was this side, right? So I'm just going to set this equal to c. And now I'm going to evaluate that function when x is 5, because that was the question. I've got 1 over 5 plus 4 is 9. The square root of 9 is 3 plus 3 equals c. So I would say c is equivalent to 1/6. So maybe that feels like a lot came at you. Again, we just went back to our definition of a limit. The two sides must equal each other and equal the function. So we just set the two functions equal. We had to rationalize this piece because it has the radical in it. And we got indeterminate 0 over 0. And we just solve for that value of c. So I've got one more example that's pretty similar. They gave us a piecewise function for h of x. And again, they want to know if it's continuous. So to me, the calculus word jumping off the page is continuous. So immediately, I'm taking that limit definition. The limit as x approaches a from the left, I'll use h of x since that's the function. equals the limit as x approaches a from the right equals h of a. So again, I'm saying the left side and the right side are coming together, and that point in between there is closed. All right, so in order to do that, I'm just going to set those two pieces equal. So I have 3x over x e to the x equals k. Okay. And I'm going to substitute in my value. Of course, my breakpoint is 0, so I'm always going to use that breakpoint unless otherwise stated. So you'll notice I get 0 over, so 3 times 0 is 0. 0 times e to the 0 is 0. Just to remind yourself, e to the 0, anybody to the 0 power is 1, of course. So 1 times 0 is 0. I get 0 over 0 equals k. So again, my answer is not 0. Does not exist. It's indeterminate. Keep going. So go back. What can you do to this function? Hopefully, I'm hoping you see it right away because it's nothing very fancy. It's just a simple dividing. You have an x on top and an x on the bottom, and they just simply divide each other out. So I'm going to say 3 over e to the x equals k. And then plug in my 0. So I have 3 over e to the 0 equals k. E to the 0 is 1. 3 divided by 1 is 3. So k must equal 3. And there you have it for those piecewise functions.